Okay, we're going to take a look at graphs of functions. And a lot of this course is based on coming up with a equation or a function and taking a look at what's going on with it. What does it do? What are its properties? Okay. So, in the past, you guys have, been given an equation, you pick some points, you plot some points, and you go from there. It's extremely tedious to do such a thing. You guys know how to add, subtract, multiply, and divide. So what we want to do is we want to move this up a little bit more. Okay? Makes life a little bit easier. So, one of the things that you need to pay attention to, now a graph is complete if it shows the basic shape of the graph, important points on the graph, including points of the graph across the axes and points where the graphs turn. Okay? And suggest what the unseen portions of the graph will be. Now, there are a lot of times that when you're going to graph something, you're not going to get the full picture. Again, you want to make sure you know where it goes through the x-axis and the y-axis. If it's going to be, quadratic, and in this case, I know that I got x cubed. I have a basic idea of what that shape is going to be. And as we go on, you'll pick this up as well. But x cubed, I mean, it's going to kind of come up, and it's going to go down, and it's going to go back up again in some way, shape, or form. All odd-powered functions come from, say, the bottom left and go to the top right. Or if they come from the top left, they go to the bottom right. They're always going to be some kind of a diagonal shape in there. Okay. Anything that has got an even power, if it comes from the top, it's going to do some stuff and go to the top again. If it comes from the bottom, it's going to come up and go back down again. This is just the way things are. So, what I want to do is I want to take a look at this. So if you got your graphing calculator handy, okay, I want to put this information in here so that I can go through and use it, and I can come up with some kind of a graph for it and see what's going on with it. Now, first thing, always reset the calculator. So again, that's going to be after you turn it on with the on button, you hit second plus 712. That way it's been reset back to its normal parameters and you don't have to worry about much of anything else. Now, we're going to put the equation in. Now, the equation that we've got here happens to be y is equal to x cubed minus 3x. So we just hit the y equals key up there. Then we take x, raise it to the third power, subtract 3x. Okay? So when I hit graph, I see this. Now, does this graph look exactly what they've got down there in their figure? But you'll notice that it's on a different scale. You'll notice here it goes from -3 to 3. So if we press the window, we go down for x, let's change that so that it goes from -3, clear that out, set -3 to 3. And it's going from -20 to +20. So we'll go down here and edit this, 20 to 20. And if I hit graph again, now, does this look more like what they've got? So one of the things that you need to keep in mind when you're graphing out is if they give you a picture of it, you've got the window there, make sure that your window up here matches what they're giving you down here on their graph. And how in the world do you translate this into a graph paper for yourself? you need coordinates yet still. If you hit the second and the table, you can scroll through this up and down as you need to, but you'll notice that they give you coordinates. So I got x, -3, -18, -2, and -2. It's just like what they've got here on the table. So if I hit second graph, it takes me to the table. It gives me all of this information here that I need so that I can plot those points. When I take a look at this, I've got a general shape of what the graph does, and so I know where things are going to go. It's a very easy way of dealing with things. You don't have to worry about trying to put in, plug it in, figure it out. Takes all the fun out of it, right? So again, they kind of give you some deals here for going through, and you can use Zoom or the graph, or you can do a lot of things with it. And there's a lot of ways if you played with these things a bit, and we have in the past. You got kind of an idea of what it is. So, gives you a little bit more information about what X-min means and X-max, and Y-min, Y-max, Y-scale, X-scale, and those sorts of things. So, reset the calculator again. And when I reset it, it always takes it back to the standard window. So whenever they ask you for the standard window on the graphing calculator is always going to go from -10 to 10 on both the X and the Y. So, put the equation that they got there. They've got x to the third power minus 3x squared minus 13. And when you graph it, you see this. Looks kind of boring, doesn't it? Well, there are some things that I do know. Okay? The way this is shaped, does it have to cross the y-axis someplace? You'd think so, right? But it looks like it's got to do it way down here. How far down? Well, on the graph itself, we've got this right up here that says we've got x cubed. We've got x cubed up here. X cubed minus 3x squared minus 13. And where's the y-intercept at? Isn't it going to be here at 13? So that means that whatever I do here on the window, I probably want to bring that down below 15, right? Or down below 13 so that I can see what's going on. So I'm going to go down here to the y minimum, and I'm going to change it to say 15. Because that would definitely go down far enough for 13, right? Graph it, see what we get again. So now I see that. I see a little bit more of it, but do I get to see all of it? It looks like it's going down and coming back up again. So I would want to go through, let's go down to say -20. That should help it. And you could have done that to begin with. It really doesn't, whatever it takes. So now, do I get to see all the interesting stuff with this graph? And the answer is yes. I see that it's crossing the x-axis. I see that it's crossing the y-axis. It comes up, goes down, goes back up again. So it looks as though I've got all the interesting points. And this graph is just simply going to continue going down this way and continue going up that way. It's not going to do anything interesting or weird someplace else. Okay. Don't worry, we'll get to the point where we'll be able to determine whether it's doing weird and strange things elsewhere. Does it seem straightforward? Easy enough? Makes sense? So, let's see. Don't believe We could go over and deal with this also in terms of a spreadsheet. Now, the only reason why I really don't like playing with the spreadsheet as much to do this type of stuff is when I create the spreadsheet, I actually have to tell it what numbers that I want to put it down here. It takes a little bit more work to go through and do. Can I get a bigger picture out of it? Yeah, well, I can increase it out to the size. I can do a little bit more with it. But generally, for what we do, a graphing calculator is going to be more than sufficient. This takes a little bit more manual manipulation in order to do something, but it's easier. Okay. Let's see. Now, here is something that you need to catch on to. It's that between 1950 and 2008, the percent of the voting population who voted in presidential elections is given by that function. Where X is the number of years after 1950. Okay? That is the input variable to represent 1950 is 0. We do this so that we don't have to mess with 1,950 other places that come before it. We can adjust it on the graph. So, if I want to go through and graph this out again, I'm not going to hit the reset because I know I'm going to end up playing with a lot of things. So I'm going to hit clear. I'm going to put in 0.0155 x squared minus 1.213x plus 75.26. Okay. Now, before I even hit graph on this thing, because if I hit graph on it, I ain't going to see doodly squat. I'm going to go to Window. This is real live data. It's talking about something, giving us information about something. So, do I care what's happening in the negative? Because if the x in negative 10, that represents 1940. I don't care about that. So I'm going to put that into 0. Okay, because 0 was starting at 1950. I'm supposed to take this out to 2008. How many years should I go out? 60 would be a good amount because that takes me out to 2010. Why minimum? Again, do I care about what's happening? I mean, are we ever going to have negative voting? Well, negative. You get the 0. Okay? Can't have a negative number of votes. What's the maximum? Okay. Now, this problem is talking about percentages, correct? So what would the highest percentage be? 100. So I'm going to put my window up here probably at Y max. I'm going to go to 110 because I don't want to have the number, just cut off. I would like to see what's going on a little bit. So I hit graph, and I see that it's coming and coming and going and going and going, and it does slowly start going up. Okay. And if I take it out far enough, we should have over 100% voting, right? That's not going to happen. There are some politicians, I'm sure, that would enjoy more than 100%. But this gives you a way to find what these values are. And now it says, what are the values that correspond to the years 1960? Well, 1960, I would hit trace, and what number would I put in for X? Well, I wouldn't want to put in 1,960 because that's out there someplace. We started at 0. 0 is 1950. So what number represents 1960? 10. So we put in 10. And it tells me in 1960 then that there was 64.68% of the population voting. What if I wanted 2008? Well, I'd have to put in what number then? 58. So if I put in 58 on the trace and I hit enter, it tells me that there's 57.048. Okay? That means that if this model is accurate, that there's 57.08% of the population, or 048, voted in the last presidential election. That's if the model is correct. That's all it is. It's really not all that difficult. It's just plugging it in, seeing where it's going to go. Now, determining the viewing window was probably the trickiest part of the whole thing that we just did. Sometimes all you got to do is just hit second table if you're having no idea what the numbers are. You go over to the table, you can kind of see where are the numbers at? What are they talking about? Okay, give me a starting point, ballpark. So, if I try this one, it says, using data from 1960 to 2009, personal savings rate as a percent of disposable income can be modeled by the function. So, y equals again. You see clear, get rid of that. So point, we get 1, 2, 3, 4, 9, 6 x to the third power minus 0.0387 x squared plus 0.714x plus 6.787 window. Okay. Wants us to take this out from 1960 to 2009. Starting at 0 makes sense again, correct? Because we could care less what's happening behind this. Or for what really is, this model is only valid from 1960 on up. I'm going to keep 60 years in there. That's still acceptable. Let's see. X max, I could leave that at 110 because I want to see if it ever gets up to 100% savings. But now, let's think about this for a second. Are we ever going to see 100% savings? In other words, everything that you make, you're saving, not spending a dime. Is that going to happen? Probably not. So I want to make a guesstimation here. It says that it starts off at about 7 or 6.787%. That's the y-intercept. Oh, let's see. Maximum savings. Let's say that the maximum savings is at most 15 or 10%. So I'm going to put myself at 15 just so that I can see. And when I hit graph, okay? Okay. Not bad. So, we chose an appropriate window. We graphed it out there. Now it wants us to model a personal savings rate in 2013. So, 1960 to 2013, how many years is that? So we're going to hit trace, put in 53, enter. Okay. So what they're saying there, according to this model, in 2013, the savings rate was 5.74%. Okay, so that's what was being saved, 5.74%. Does that seem reasonable? I guess so, according to this model. It does, though, doesn't it? That's really all that we're taking a look at here. So if I continue on, they show you a few things on how it looks. They had things set up a little bit differently, which is perfectly fine. Perfectly fine. Let's see. Continuing on here, and again, like I said, you can put this into a spreadsheet, but it's going to take a little bit more to do. Let's see. Graphing data points. Now this table here gives the number of executions in the United States as for selected years from 1984 to 2008. Okay. Now it says align the data so that X is the number of years after 1980. So what would I use for my Y coordinate then, or my X coordinate, if it's supposed to be the years after 1980? Whoops. Well, won't that just be 4 and 7 and 10 and 13 and 16 and 19, 22, 25, 27, 28? Isn't that just what it would be? Just start at 1980 and start counting. Now, let's see. So what we're going to do here is I'm going to show you another way that you can deal with these points. What I want to do is, let's see. So, what I want you to do is hit the stat button. If we're going to put in data, we start with stat, we're going to hit edit, we press enter. This takes us to the register. L1 we generally use as X, L2 is at Y. So if I want to put this data in here and have it show up on the graph, I would end up putting in 4 here, correct, for the first one. Then we said 7, 10, 13, 16, 19, 22, 25, 27, 28. Arrow key over to the right, L2. So now we can put in this data. We don't have to edit that, do we? Or adjust it. So it's just going to be 21, 25, 3, 38, why did I do these? 45, 98, 71, 60, 42, 37. Okay. So I got all the data typed in. Now, we got to turn this on so that we can actually see what's going on. I'm going to hit Y equals here to begin with, or actually I got to go to second quit to get me out of it. I go to Y equals, I want to clear that equation out because I don't want that showing. Hit second Y equals because that puts the plots in. So by hitting the second key, the Y equals key takes me to this. You'll notice it all says off right now. So I'm going to press enter. One of those days when things just don't play your way. So I hit enter. You'll notice how it's going and flashing on the on. If you press enter again, now it turned it on. This tells me that it's just going to plot dots. X list is coming out of L1, Y list is coming out of L2, and it's going to use little squares to do that. Now, window. Is 0 to 60 going to be good for us? Well, no, because we started at 1980 and we went to 2009. So I don't need 60. I could probably only go up to 30, right? That makes sense to do? Why minimum? Well, we didn't have any negative executions. I think that'd be called Earth, right? Slow crowd this. So, what should I put this up to? Well, the highest one I see is 99, so I'm going to go to 100, or 98, so it's 100. So now when I hit graph, I get a scatter plot of the data. handy, isn't it? So, let's continue on. So, they've got the data, they've got that. There we go. Again, you can do the same thing with the spreadsheet. Type the data in and use the table generator or graph generator, and away you go. So, make sure that you always pay attention to the alignment and scaling. I mean, there are times that you don't necessarily want to count by ones. Counting by tens would be more advantageous. Keep these things in mind. And that be all that I've got for